Here we are at 19b from our Chapter 2 targets. We're asked to write this as a piecewise function. Well, the first step that we're going to do is go ahead and solve for y. So we're going to do that by adding 4 to both sides. On the left, they just end up canceling out, then leaving us with y is equal to the absolute value of 2x plus 1 plus 3. Now our goal here is to again write this as a piecewise function. And in order to do that, we first then have to determine what is our vertex. Because the vertex is really what tells us the break from our two different functions. Now to find the x value, we're going to go ahead and take whatever is inside of our absolute value and set that equal to 0. So we have 2x plus 1 is equal to 0, and then we're trying to solve for x. So it looks like we'd end up then with 2x is equal to negative 1, dividing both sides by 2. Looks like x is negative 1/2. Now for our y value, we pretty much just drop him into our point, and again, that would be our y value. So we'd end up with negative 1/2, comma 3. So this is our vertex. Now, when we're trying to figure out what is our piecewise function, we have y is equal to two different parts. And again, these breaks are happening specifically at our vertex. So when x is less than negative 1/2, and when x is larger than or equal to negative 1/2. And the reason for that is because we have some v either going something like this, or something like this. And what determines whether it's facing up or down like that is actually that a value in front of our absolute value. Well, we know that our a value in front, if it's not written, it's assumed it is 1, and that implies then that we have a positive a value. So we are actually looking at a v doing something like this. Now what we're going to do is we're going to take our function y is equal to the absolute value of 2x plus 1 plus 3, and instead of these absolute values, we're going to substitute in a parenthesis with that. For our other one, we're pretty much just going to rewrite literally the same thing. Y is equal to 2x plus 1 plus 3, but instead we're going to add a negative 1 in front of that. We're going to multiply this parenthesis by negative 1. And the reason for that is, again, really you have a 1 in front of this parenthesis, and this 1 and this 2 are what control our slopes. But when you multiply it by negative 1, you're then ending up with your negative 1 slope. And then over here you'd have that positive slope. All right, so this is what would give us our negative slope, and then we, for our other one, have our positive slope. So then just solving for each part of our piecewise, we have 2x plus 1 plus 3. And as a result, looks like we end up then with y is equal to 2x plus 4 for this part of the piecewise. Over here, we would end up with y is equal to negative 1 times 1 is negative 1 times 2x plus 1 plus 3. Distributing in this negative 1, we would end up with y is equal to negative 2x, looks like minus 1 plus 3, which simplifies out to be y is equal to negative 2x plus 2. So here are our two parts of our piecewise functions. Again, creating those lines. So again, because we have an absolute value function that looks something like this, we see that for x values that are to the left of our vertex, we have that negative slope. So then just looking at our two lines, we see that this guy has that negative slope. So then this would be our left part of the piecewise function. And again, these are x values that are less than negative 1/2. So this is where we would see that negative 2x plus 2. For anything that is larger than or equal to negative 1/2 for our x value, we would use then this 2x plus 4. And the entire reasoning behind that, again, is because we know the general shape of our graph, at this vertex, negative a half, 3. On the left side, we have that negative slope. On the right side, we have that positive slope. So that's how we knew which function was which. But again, that is 19b from our Chapter 2 targets.